questions with circles, radius, and area. Here's the diagram we're going to be using. Basically, the question is simple. If you have two overlapping areas of a circle with both the radius r and the intersection L, what is the overlapping portion in terms of r and L? So basically, we have r. We know that these are two identical circles. They both have a radius r. And we both know the overlapping intersection is L. So what is the area of this part here? So, yeah. Let's do this. Well, first, I redrew the diagram with a few extra lines. So we have line B here, line A is this big line here going down. We still have lines R. We also have X. We also know that this is L still, but we're basically going to explain that in the next portion. We have O, C, D, E. This is basically for lines and segments, which are going to be what basically when we're talking about the curved part as well. Whereas when we talk about triangles, we're just going to talk about the straight edges. So basically, we know that these two are L. We know that because why is that? Basically, let's look here. R, the overlapping section is L, but think about it. We have two layers of L. That's why you can see that this is like darker, right? So we have to remove that L. We're then gonna denote half B equals D, half A equals C. It doesn't have to do anything. That's just to simplify things. Here's my strategy for overlapping. First, we're gonna solve for the overlapping terms in terms of D and C and R, right? Which basically means B and A. So first we're gonna solve for it in terms of B and A, then we're gonna solve for it in terms of R and L by realizing the relationship between B and A. And you can obviously see we're gonna use Pythagoras, right? So now let's get started. The circles are symmetrical because they're identical. We can assume both segments are equal. CE of CE are equal. Therefore, the shaded area is basically 2CE. What do I mean by this? Segment CE, right, with the line CE is basically this part. Two of these are basically the same. So that means let's move on to the next part. We can solve for segment CE. Basically, it's segment COE, which is basically this part, this cone-like thing here, minus triangle COA, which is basically this triangle here. So let's get started. We know that triangle is half base times height. We already have that, half BA. Segment CRA is basically this pi r squared, the area of a circle, divided by its radius, which is 2x. Basically, so now we have to solve for x, right? In terms of C and D, sine is CD, which can also be C sine AB. So I don't have to simplify like this. And I even expanded it further by including the half BA here as sine BA half times 2. Yeah. Oh, shoot, I missed the 2 there. Oh, no, there's already a 2. Sorry, I see where the half went. This is a half, so therefore the 2's are the same denominator. And then, yeah, then I continue. I then have to solve for A and B in terms of right now. We know B is this. We know D is this. So we can see this is where the D part is. This is a right angle triangle, but half B and half A. That means we're using D and C. So first let's solve for D and C. We know what D is, R minus half L. Basically Pythagoras, solve for C, substitute that, times it by 2, which is going to give you 4. Put that inside. That's going to give you 4RL minus L squared. Basically, that means that the colored part is basically this part substituted with values A and B as denoted here, giving us this huge equation here. How exciting.